Hi everyone, welcome back to my channel. We're going to go over this homework assignment right here. All right, so simplify and express the following as a trinomial. That means we want 3 terms in our final answer. So we talked about that thing called super zoom. What are we going to super zoom to? We're going to zoom to that binomial squared. All right, so this is what you should be doing on the side of your paper. X minus 4, we're going to expand that out. X minus 4 squared is really X minus 4 written twice. All right, so this is x squared minus 4x minus 4x plus 16. And when you combine those middle terms, you get x squared minus 16x, minus 8x, right? Plus 16. So now that we have the binomial squared, let's take a look at what our problem is really asking. The problem is telling us to multiply x minus 4 squared. Well, we know 5 times x minus 4 squared. X minus 4 squared is really x squared minus 8x plus 16. So we're going to add that on. And then we're going to subtract 9x minus 2. So now, once you have this set up, we literally just carried this there because this is the same thing as x minus 4 squared. We just double distributed. Now we're going to do this times this and this times this, and then combine all of our like terms. So after I've distributed, now I'm going to combine my like terms. I have x's, all right, and I have constants. So my answer will be 5x squared minus 49x plus 82. All right, on to the next. Factor the given expressions completely. Now, oftentimes when you see factor completely, that means factor more than once. All right. Now, let's look at this one right here. It's 2 terms. Is a GCF dots a trinomial? 2 terms, difference of 2 perfect squares is going to be x squared minus 9, x squared plus 9, because this is dots. Now, look at your factors now. See if you can factor something again. X squared minus 9 and x squared plus 9. Which one is dots? Which one can be factored again? This one can be factored again. This one can be factored again. This one here needs to come down. This can break up into x plus 3, x minus 3. So that's that one. For B, this is a trinomial, so trinomial is always double bubble, okay? Now, the only difference here is that's x to the 4th in the middle, so you're going to make sure it's going to be x squared in each spot. Now, what is going to multiply to negative 7 and add to positive 6? Now, this middle sign comes down. Since it has to multiply to a negative, we assume that it's going to be the opposite signs. So multiply A and M. Multiply to negative 7. What multiplies to negative 7? Well, negative 1 and positive 7. So that's going to be 1, 7. Which one can be factored again? Do you see a dot somewhere? Right here is another dots. This one we bring down. X squared plus 7, can't touch. X minus 1, x plus 1, because this can be double dots. Okay? Next. All right, calculate the zeros of the quadratic function by factoring completely. Before you can factor, you always have to set equal to 0, so that's what I did. I took everything from the right-hand side and I moved it over. So now I'm going to factor completely. All right, this is a trinomial. So what trinomial, we see that this number is out front. You're going to circle it and multiply it to the back. So what you're factoring now is x squared minus 1x minus 12 is equal to 0. Now that you have a regular trinomial, you can set yourself up with your double bubble, x and x, because we're multiplying to x squared. Now, what is going to multiply to negative 12 and add to negative 1? So negative 12, let's think. How about negative 4 and positive 3? Okay, so this is going to be negative 4 and positive 3. Now, since this is a tricky trinomial, we have that 2 circled for a reason. We're going to divide it out. So there's going to be x minus 2 as our first factor, and does 2 go into 3? Nope. So we're going to bottoms up. 2x plus 3 equals 0. All right, so now we are solving, so we need to make sure that we are t-charting our two factors. X minus 2 equals 0 and 2x plus 3 equals 0. Let's solve each one separately. So our first 0 is 2. That means our parabola is going to cross at positive 2 somewhere. Okay, and then let's do the other one. I'll do that off camera, off whatever. So the next solution is going to be negative 1.5. You subtract the 3 over, then divide by 2. Yeah, so that means my parabola is crossing over at 2 and negative 1.5. So it's going to look something like this. This is beautiful. Okay, next question. All right, so here, what are the roots of the equation x squared plus 6x plus 7 equals 0? Express the answer in simplest radical form. Oh, it's already said equal to 0, so I can use my quadratic formula. That a lot of you rather use the quadratic formula than factor, which is cool. All right, so x is equal to negative 6 plus or minus the square root of 6 squared minus 4 times 1 times 7. All over 2 times 1. All right, so I'm going to get that number under the radical, but first I'm like setting myself up real nice. The number under the radical should be 8. Let's put this in our calculator. You're going to do y equals 8 divided by x squared. And you should get that this is x is equal to negative 6 plus or minus 2 radical 2 over 2. Now last step is just to do that little heart method thing. So x is equal to negative 6 divided by 2 is negative 3 plus or minus 1 radical 2. Now, simplest radical form means your answer isn't going to be a whole number, so that is like a major hint, quad formula. Okay. Next. All right, last but not least, Miss Tomei went to Dollar Days to buy pens and pencils for her classroom. Pens cost $1.05 each, and pencils cost 90 cents each. Miss Tomei spent a total of $18. Write an equation to represent the possible numbers of pens and pencils that Miss Tomei could have purchased. I'm going to write it. Okay, so this is your first equation. $1.05 times the number of pens plus 90 cents times the number of pencils is equal to $18. This represents the possible numbers of pens and pencils. Now, Miss Heschel butts in and says that Miss Tomei might have purchased 13 pens and 9 pencils. Are Miss Heschel's numbers possible? Use your equation. So that means use the equation you just made, and you're going to substitute in the values. So I'm saying, are the 13 pens and 9 pencils? Well, let's see. That has to equal 18, does it? It's actually equal to $21.75, which is not equal to 18, so it's not possible. All right. Then Miss Heschel went to Miss Tomei's classroom and found out that she bought a total of 18 pens and pencils. Write and solve a system of equations. That means we need 2. So between the pens and the pencils, she bought 18. And then we're just going to drop down our other equation. Okay? So now we have to solve this system. This is our system. We have 2 equations. Multiply the top by whatever is going to cancel out 1.05. Multiply the top by negative 1.05. And distribute. So we have negative 1.05x minus 1.05y is equal to negative 1.05 times 18. That's negative 18.9. And then you keep going. So now those x's will cancel. 0.9 minus 1.05 y, that's negative 0.15y, is equal to 18 minus 18.9. This is negative 0.9. Now to solve for y, we're going to divide both sides by negative 0.15. So y is actually equal to 6. So that means there are 6, what did we say? Y is the pencils. 6 pencils. Now, we have 18 total. Between the pens and the pencils, we have 18. But now I know 6 pencils. How many pens did we buy? 18 minus 6 means x equals 12. So we're going to have 12 pencils and 6 pens, tills, and 12 pens. All right, guys, I'll be here in the morning. Best of luck studying. I'll be praying for you. #blessed for tomorrow.